At the Airbus Defence and Space Compact Antenna Test Range facility in Ottobrunn, Germany, the antennae of the new EDRS-C satellite are undergoing a final testing. After this, the satellite will be shipped to Kourou for launch. EDRS-C is the second node of the European Data Relay System and the first dedicated EDRS satellite. The first node, EDRS-A, was launched in 2016 as a hosted payload on Eutelsat 9B and has been providing fully commercial data relay services to the Sentinel satellites since 2018. EDRS-C will add additional capacity to this system, improve its robustness, and further increase the coverage as it will be in a different geostationary orbit from EDRS-A. With EDRS, ESA and Airbus are aiming to improve and accelerate data transmission from low Earth-orbiting satellites to the ground, where conventional data transmission has severe limitations.
Low Earth orbit spacecraft can't always see their ground stations, which are fixed on the ground, whereas the low Earth orbit spacecraft are revolving around the Earth. On the contrary, EDRS is motionless with respect to the Earth and oversees half of the Earth surface, which means then EDRS is much more visible to a low Earth orbit spacecraft compared to a ground station.
From their geostationary orbit, EDRS satellites can both see the low-orbiting imaging satellite as well as the ground stations. The data from the imaging satellite can be sent via a laser link to EDRS, which then transmits data via radio frequency to the ground stations in Europe. This allows for longer data transfers, as the connection can be maintained for a much longer period of time, and which are also faster due to the high speed of the inter-satellite laser link. With the conventional approach of using polar ground stations for a direct download from the imaging satellite, this connection could only be established for about 10 out of every 90 minutes. The EDRS is the first commercial system in the world to use optical communication between satellites. One of the main technical challenges has been to guarantee the accuracy and stability of the laser link required for a reliable transmission. However, the benefits in terms of speed and data capacity have been worth the effort put into it.
EDRS is called a space data highway because it's likened to an optical fiber in the sky. It's a highway through which data travels at enormous speeds. In the case of EDRS, at up to 1.8 gigabits per second. And if you compare this to a conventional internet connection at home, you can say that it's about 100 times the speed that you get with your internet connection when you surf at home. So that's a real highway for data in space.
The main features of EDRS are its high transfer rate and its near-permanent availability. This results in a quasi-real-time availability of the data on the ground, making EDRS ideal for relaying time-critical and sensitive information from Earth observation satellites to, for example, emergency response teams and security services on the ground. This innovative system is the result of a public-private partnership between ESA and Airbus Defence and Space, in which ESA and Airbus have jointly developed the infrastructure and Airbus operates the service. ESA and Airbus are already working on a third node, EDRS-D, to be positioned over the Pacific Asia region as another step towards worldwide use of this breakthrough technology.
The ultimate goal will, of course, be to achieve global coverage so that we can transmit imagery that is taken anywhere in the world to Europe within quasi-real time, meaning almost immediately.
The EDRS system is a unique system. No one on Earth we ever implemented a commercial operational system using laser communication. In that sense, Airbus, and specifically ESA and DLR, are leading here in the world.
Both ESA and its industrial partners are convinced that optical communication in space is a key technology in order to fully exploit the vast amounts of data generated by the latest generation of low Earth orbiting satellites. EDRS opens up a new era in space-based telecommunications, and the launch of EDRS-C is another step towards the completion of the space data highway.